Hi everybody, we are about to solve exercise 12, chapter 3, production decisions. So we have alpha, that is a company, and then here we are given the production function of alpha, that is this one, so k capital to the power of 1/2 times L, where Q is output, K is the capital, and L is labor. Alpha's marginal rate of technical substitution is 2 times K over L. The hourly wage is 8 euros, while R is equal to 1 euro. Okay? So we start with the short run. Okay, so let me underline this. We are in the short run. Okay, and we have K as expected, fixed, equal to 4. We need to know how many units, we need to find out actually, how many units of labor should the firm hire to produce 16 units of output in the short run. Okay, so first of all, let's make clear again that we are in the short run. And so K is fixed. And in our case, K bar is equal to 4. Okay. Okay, we need to find how many units of labor should the firm use to produce a target Q equal to 16. Okay, so the question is how much L? K is 4 for sure, but you tell me how many workers you need to achieve this goal. That's the point. Okay. To answer this question, we need, first of all, to write the production function in the short run. Okay, so we first write alpha's production function in the short run. In the short run. Okay. So we have that the production function is Q of K and L equal to K 1/2 times L. In this case, since we are in the short run, we put a bar here. Okay, so we have Q that depends on K and L equal K bar 1/2 to the power of 1/2 times L. Okay, so we can substitute the information on K we are given, that is 4 to the power of 1/2 times L, okay, meaning 4 to the power of 1/2 is equal to 2, so 2L, okay. So the production function is Q of KL equal to 2L, okay. Now, since we have the target Q that we want to produce, and this is 16, we can write 16 equal to L. And from here, we find that the L needed, so we call it L star, is equal to 8. And we have answered. Okay, so that's the answer to this first point of the exam. Okay, we now go on with point 2 of our exercise. What are the short run? We are always in the short run. Total costs to produce the 16 units of output we have just seen in point 1. Okay, so the total cost of producing 16 units in the short run are given by the salary times the amount of labor we use plus the unit cost of capital times the units of capital employed in the short run, K bar, because again K is fixed in the short run. So we have 8 times, because the wage is 8, L star is 8, so 8 times 8, plus R is 1 and K is 4. Okay, so we have 64 plus 4, 68. Okay, so in the short run, producing 16 units of output as a cost of 68. Okay? Okay, and now we can move to point 3 of the exercise. So if good Q were traded at the competitive price of €5, so now we know the price, that is 5. What profits would Alpha get from selling again 16 units of output in the short run? Okay, so we have to compute the profits related to 16 units. Okay, profits are given by total revenues minus total cost. Total revenues are given by the price times the quantity minus total cost are total cost. So the price is 5, the quantity is 16, and the total cost, we have just computed them for 0.2, and they were 68. So we get 80 minus 68, 12. And that's the profit. Okay? So in the short run, the profit would be 12. Okay, we now move to point 4. Okay, we have now suppose that alpha operates in the long run. So we change. Now we are in the long run. And therefore can change both the number of working hours, so the units of labor, and the units of capital employed. We have now to compute alpha's optimal combination in the long run to produce again 16 units of output. So now everything changes because we are in the long run. The only thing that is the same is our target Q, that is 16. Okay. Now in the long run, it means that the company can choose and vary both inputs. So not only labor, both inputs. Okay. So we have to know the optimal combination. So in order to say what is the optimal input combination, first of all, we have to understand what kind of technology alpha is using. Okay. So from the production function that we are given, okay, we see that alpha's technology is regular. So basically it is a Cobb-Douglas production function, okay? So in order to find the optimal input combination, we set up a system. The optimal input combination is given by a system where, first of all, what do you put in this system? First of all, you put the target isoquant, meaning the isoquant associated with the level of output you want to produce, together with the condition of the marginal rate of technical substitution being equal to the cost, to the ratio of the cost of the two inputs. So the wage over R. R is the unit cost of capital. So for us, the target isoquant is given by, basically, how do you get the target isoquant? Okay, you substitute your target Q, okay, into the production function. Production function. Okay, so we have that our production function was Q equal, so instead of Q I put 16 because that's my target Q again, equal to K to the power of 1/2 times L. Then we are given the marginal rate of technical substitution, that is 2K over L, equal, the wage is 8 and R is 1. Okay, so we have to solve this system. here. Okay. So we now go step by step solving this system. Okay. So we rewrite the target isoquant or isoquant of reference k to the power of 1/2 times L. Here, basically, we work on the second equation and we have L. So we have 2k equal 8L. We can get k out of this. So we have k equal to 8 over 2L. So we have k equal 4L. Okay. We substitute this into the isoquant. Okay. And so we have 16 equal to bracket 4L to the power of 1/2 times L, and here k equal 4L. Okay, we go on with the computations again step by step. And we have. So I rewrite here the last step just so that you have everything here. You can see it. It was 4L to the power of 1/2 times L, and then we have k equal 4L. Okay, so we now compute and we have 16 equal 4 to the power of 1/2 is 2, and then we have L to the power of 1/2 times L, and here k equal 4L. So we can write this as 2. Then we have L to the power of 1/2 times L. So we can sum up the exponents. And so we have 2 times L to the power of 1/2 plus 1. Because this is it is as if L here as the, is at the power of 1. So we can write 16 equal 2 times L to the power of 1/2 plus 1. K equal 4L. So we have 16 equals 2 L. Here we have 2 and we have 1 plus 2. Okay, and K equal 4L again. So we have 16 equals 2L to the power of 3 over 2 finally. Okay. So now we have to get L out of this. Okay. So here I write k equal 4L. So let's rewrite it as 2L to the power of 3 over 2 equals 16. So we have L to the power of 3 over 2 equals 16 over 2. So L to the power of 3 over 2 equals 8. And now we have to solve this, okay? So I write it bigger here. We have L to the power of 3 over 2 equals 8, okay? To solve it, we have to put everything to the power of 2 over 3, because so doing, here we get simply L to the power of 1. And here we have 8 to the power of 2 over 3, and we can write it as a root. Here I put 3, and here I have 8 to the power of 2. So we get L equal to, again, and now we compute and we have 64. And this is equal to 4. So finally, we have computed that we have an optimal amount of L equal to 4. And then K star is equal to 4 times L star. So 4 times 4, so 16. Okay, so the optimal combination of inputs is 4, so L equals 4 and K equals 16. We computed it. Okay. And we have answered everything for this point 4 that was asking the optimal combination. Okay, we have gone through the computation step by step, okay, just to show everything. And now we have point 5 here. So what are the company's long-run total cost to produce 16 units of output? Compare them with the cost that you find in point 2. Okay, so now we compute basically long-run costs. Okay, so again, total cost of producing 16 units. Well, the expression to find them is exactly the same. You have to compute the salary times the amount of labor that you use plus the unit cost of capital times the units of capital that you employ. Okay, so we have that the wage is 8. Now L in the long run is 4 plus 1 times 16. Okay, and you find 48. If you remember correctly, the total cost of producing 16 units in the short run was 68. So we can say that the total cost of the long run is lower than the total cost of the short run. Okay. Does this make sense? Yes, it makes a lot of sense. And actually the total cost in the long run are lower than those in the short run because now the company can choose and vary both inputs. So it is more efficient. Okay. And now the last part, the last point of the exercise, point 6. We have, in order to reduce Alpha's production cost, its managers propose a business restructuring. The business restructuring modifies Alpha technologies. Okay, so we have a new production function. Okay, new production function. That is 4k to the power 1/2 times L. Okay, the previous one, the old one, let's write it, was simply k 1/2 L. Can you say without making calculations, so meaning just reasoning, if the restructuring would allow Alpha to reduce its production cost? Motivate your answer. Well, the answer is kind of simple in the sense that the difference is given by the fact that now the production function has this 4 times. Okay, so it means that now the firm is more productive. So both labor and capital's productivity have increased. So the answer is yes, it will allow Alpha to reduce the production cost. Okay, so the restructure will allow Alpha to achieve lower production costs. And This is all for this exercise.